Assalamu alaikum. Good morning. First of all, I would like to thank the organizer of First National Conference on Applied Science and Advanced Material, SCIGDA, Algeria. So, the title of our contribution is Structural and Electronic Properties of MgU doped with Uranium Transition Metal. Presented by me, TAYEB HALAIS WISSEم, PhD student from L2PM laboratory, in order to direction of Chettibi Sabah, professor of University of Galma, Algeria. The outline is as follows. I will to present small introduction, then I will talk about the method of calculation, next I will show the results, finally I will give a conclusion. Magnesium oxide is a non-magnetic compound stable in the rock salt structure. It can be employed in catalysis, microelectronic, and different other applications. The properties of MgO change when doped with transition metal atoms. We choose the 5D transition metal rhenium to see the effect of this metal on structural and electronic properties of our oxide. To evaluate the property of doped MgU, we utilize the first principle calculation based on full potential linear augmented plane wave plus local orbitals without the Wayne-2K code, using the GTAPBU approximation. For the results, structural properties. Figure 1 shows the crystal structure of MgU and MgU doped uranium. The structural optimization for Mg uranium oxygen at 0.12 concentration as represented in figure 2. The total energy and lattice constant of new doped compound were obtained by volume optimization of Mernega equation of state. The lattice constant, bulk modulus, and its derivative are displayed in table 1. The comparison of curves giving energy as a function of volume in the ferromagnetic and the non-magnetic phase presented that the compounds are stable in the ferromagnetic phase. The results from table 1 indicate a small decrease in the lattice parameters from the n-doped MgU to doped with transition metal uranium. These data were employed to complete the investigation of the structural and electronic properties of Mg uranium oxygen. Electronic properties. In this part, the band structure, density of state, total and partial of doped MgU is discussed. The band structure of binary MgU represents a direct bond gap at gamma point equal to 4.4 electron volt, while for the ternary Mg uranium oxygen it shows a metallic behavior. The results of band structure are shown in figure 3 and 4. The results of the energy gap of binary MgU and ternary are presented in table 2. Figure 5 depicts the total and partial density of state of pure MgU and Mg uranium oxygen. The analysis of total and partial does show that the hybridization between 5D uranium state and p oxygen state gives the metallic character to the doped MgU. From table 3, we may also see that the local magnetic moment of the impurity uranium is 0.5, our dominated value compared to Mg 0.001 and oxygen 0.02. In conclusion, the structural and electronic properties of magnesium oxide doped with 5D transition metal uranium have been systematically studied by the first principle calculation. The results obtained show that the ternary compound is stable in the ferromagnetic phase. For the binary compound or not, direct bond gap at gamma point equal to 4.4 electron volt. The ternary compound, it has a metallic character due to hybridization of 5D uranium atom state and p oxygen state, and doped MgU is non-magnetic, but after doping with uranium atom it becomes magnetic with a total magnetic moment equal to 1.01. Thank you for your attention.